To find square roots by factorization, these are the steps that we follow. Number one, you write the number as a multiple of its prime factors in index form. Divide the powers of the prime factor by 2. Then express the resultant prime factors in normal notation. We have examples here. So the first one, we are looking for the square root of 64. We write 64 as a multiple of its prime factors. So you realize 64, the first prime factor or the least prime factor that can divide 64 is 2. So 64 divided by 2 gives us 32. 32 can also be divided by 2. So divide by 2, you get 16. 16 can also be divided by 2. So divide by 2, you get 8. 8 can still be divided by 2. So 8 divided by 2 gives us 4. 4 divided by 2 gives us 2. And 2 divided by 2 gives us 1. So the prime factors of 64 are the ones that I've listed here. So 2, 2, 2, 2, 2, 2, 6 times. Therefore, we can write 64 in terms of multiples of its prime factor as 2 raised to power 6 because there are 6 2's here. To find the square root of 64 is as good as saying we are looking for the square root of 2 raised to power 6. Therefore, you can write root 64 is equal to 2 raised to power 6. You find that root. Now, the next step is to divide this power of 6 by 2. So we shall say 2 raised to power 6 divided by 2 will be equal to 2 raised to power 3. And this, if you write in a normal notation, it means 2 times 2 times 2. And that gives us 8. Therefore, you can say that the square root of 64 is 8. Remember, the moment we divide the power by 2, we do away with the root sign. So that's why you cannot see it here. Then the next example is to find square root of 129,600. So we first start by finding the multiple, we start by writing it as a multiple of its prime factors. So we have 129,600. The least prime factor that can divide this number is 2. So divide by 2, you get the answer being 64,800, which still can be divided by 2. So you divide by 2, you get 32,400, which still can be divided by 2. So divide that by 2, you get 16,200. This can still be divided by 2. So divide by 2, you get 8,100, which is still divisible by 2. So divide it by 2, you get 4050. 4050 can still be divided by 2. So divide by 2 again, you get 2025. Now 2025 cannot be divided by 2. So we move to the next prime number, the next least prime number, which is 3, and see if it can divide. And indeed, we realize 3 can divide this number. So we divide it by 3 and we get 675, which still can be divided by another 3. That gives us 225, which still can be divided by another 3. That gives us 75. 75 can still be divided by 3 to give 25. Now 3 cannot divide this, so we move to the next prime number, which is 5, and it's actually the one that can divide 25 5 times, and then divide this 5 by another 5, you get 1. So these are the prime factors of 129,600. Therefore, we can say, or we can write 129,600 in terms of its prime factors as 2 raised to power 6 because they are 1, 2, 3, 4, 5, 6. 6 2's. So we shall have 2 raised to power 6 times, we have how many 3's? 1, 2, 3, 4. So it will be 3 raised to power 4 times 5 squared. Now, the next step is to divide. We do away with the square root sign and we divide the powers by 2. And that is what I've done here. You can see we have 2 raised to power 6 divided by 2 times 3 raised to power 4 divided by 2 times 5 squared divided by 2. The moment you start dividing by 2, you do away with the square root sign. That gives us 2 cubed times 3 squared times 5 raised to power 1. If you write that in a normal notation, that would be 8 times 9 times 5, and that gives us 360. And that means the square root of 129,600 is actually 360. The third question was this one, root 144 over 441. Now in this question, you work out 144 differently, write it as a multiple of its prime factors, divide the power by 2, and then you write in normal notation, and you do the same for the numerator. So starting with 144, we can write 144 as a multiple of its prime factors as I've indicated here. 144 can be divided by 2, which gives us 72, divided by 2, giving us 36, divided by 2, giving us 18, divided by 2, giving us 9. Then 9 cannot be divided by 2, so we move to the next prime number, which is 3, which divides it 3 times, and then 3 divided by 3 gives us 1. So you can write 144 as 2 raised to power 4 times 3 squared, because there are 4 2's here. That's why we have 2 raised to power 4 times 3 squared, because there are 2 3's there. Then we come to 441, do the same thing. The prime factors of 441 are 3, 3, and then 7 and 7. That gives us 144 being written in a multiple as a multiple of its prime factors as 3 squared times 7 squared. Now to find the square root of 144 simply means we look for the square root of this 3 squared times 7 squared. Now I've written the question, the original question we had 144 over 441 as a multiple of its prime factors as 144 being equal to 2 raised to power 4 times 3 squared, which we wrote here, and then 441 is 3 squared times 7 squared, which we have up here, and that's the one we have written down here. Now divide the powers by 2 in both cases. So we shall have 2 raised to power 4 divided by 2 times 3 raised to power 2 divided by 2 over 3 squared divided by 2 times 7 squared divided by 2, which when you simplify, you will get the numerator giving us 2 squared times 3 raised to power 1 over 3 raised to power 1 times 7 raised to power 1, which when you simplify, you get 12 over 21.